Hello everyone, welcome to EDUKEM channel. In this video lecture, we'll discuss about very important topic, that is electrochemistry. So the first we'll discuss about the introduction, how the energy is generated and how the energy is converted to in the various forms. Next we'll discuss about electrochemical cell and its types. So basically there are two types. So our main focus will be galvanic cell. Next we'll discuss about oxidation half reaction. Next, reduction half reaction. So here is an example of part of electrochemical cell which convert the chemical energy into electrical energy. So this topic is very important for exam point of view. So without a doubt, let's start. Now introduction of the electrochemistry. So as we already know that in the nature there are various devices available which convert one form of energy to another form of energy. Okay. For example, if we'll talk about turbine. So a turbine is an instrument which convert water energy to electrical energy, right? Or you can say the fan, electrical fan. So a electrical fan is using the electrical energy to convert that into wind energy, right? So there are various type of devices are available which convert one form of energy to another form of energy. Now, in this topic, we are going to deal about only chemical reactions and chemical energy which is converted to electrical energy or vice versa. Talking about the chemical reactions, these chemical reactions can be used to produce electrical energy. Okay, for an example, battery. So a battery is an example where a chemical reaction takes place to convert that into electrical energy, right? Now, electrochemistry. So it is the study of production of electricity from energy released during the spontaneous chemical reactions. So this topic is only deal about the chemical reactions only, and those reactions are the spontaneous. As we already know that spontaneous reactions which occur itself, right, without any external energy. So we are going to deal about what are the chemical reactions involved in the reactions, which are anode, cathode, charge, how the electrons will flow, and also various type of devices. So let us start the topic. Electrochemical cell. So this is very important, electrochemical cell. So what is the electrochemical cell? It is a device that can generate electrical energy from chemical energy or use that electrical energy supplied to facilitate chemical reactions. Now we will discuss about these two process. Okay. Now, electrochemical cell, it's talk about the generation of electrical energy from chemical energy. So this electrochemical cell basically divided into two parts. One is the galvanic cell, another is the electrolytic cell. In the galvanic cell, what happens? Chemical reaction takes place to generate the electricity. So the first point is generate electricity from its chemical energy. Okay. Now, in the electrolytic cell, what happens? Use that electrical energy supplied to facilitate chemical reactions. So, in this device, what happens? Chemical are there, two electrodes dipped into the chemicals, and a battery or a external power is supplied so that this power is going to carry out the chemical reaction in electrolytic cell. Now, if we'll talk about the galvanic cell, no such external source is applied, but here what happens in the both the reaction, if we'll talk about the anode or cathode, the electricity generated by use of chemical reactions. So in the further slide, we'll discuss about how the chemical reactions generated and how the electricity produced in galvanic cell. Okay. Now talking about electrochemical cell. As we have discussed, there are two types of electrochemical cell. First one is galvanic cell. This is also known as voltaic cell. And the second one is electrolytic cell. Now, mainly our focus will be on galvanic cell. Okay. So what is this galvanic cell? An electrochemical cell that convert the chemical energy of spontaneous redox reaction into electrical energy. So the reaction is a spontaneous reaction. There is no external source applied to carry out the reactions. Okay. And this is a redox reaction. So what is a redox reaction? Where oxidation as and reduction takes place simultaneously. Okay, so this reaction we are going to detail discuss. Okay, so this is a schematic diagram. Here you can see another picture. So one of the part, zinc is dipped in zinc sulfate solution, that is acting as an anode, and oxidation reaction takes place. In the second part, copper is dipped into copper sulfate solution, and that is acting as a positive electrode, that is known as cathode. Reduction is taking place. Okay, and this is known as salt bridge, and the electron flows from anode to cathode. Remember, electron flows from anode to cathode. So this is the half cell reaction, where you can see that zinc is converted to Zn2 plus, and this is another half cell reaction where you can see that copper 2 plus is converted to copper solid, and this is a cell reaction. In the further slide, we'll completely discuss about the what are these half cell reactions, how can you write half cell reactions, and how can you write the EMF and cell reactions. Okay, now this is just take the idea. Talking about the electrolytic cell, as we have discussed, external source is required to carry out the chemical reaction. So use electrical energy to drive non-spontaneous redox reaction. Why the non-spontaneous is used? Because you see this schematic diagram where two electrode is dipped into a solution. Now if we'll remove this external source or battery, the reaction won't happen. So to carry out the reaction, we need external source. So this source is nothing but your battery. Okay, so this battery is driving the chemical reactions, and this chemical reaction is a non-spontaneous reactions. So using this battery, it will become a spontaneous reactions. Okay, so let's just talk about galvanic cell. A galvanic cell has three components. First one, oxidation half cell. Second, reduction half cell. Third one is salt bridge. So you see this picture in the left hand side. This is called oxidation half cell. And in the right hand side, this is called reduction half cell. Okay, and in the middle, which connect the oxidation half cell and reduction half cell, that is known as salt bridge. So the reaction takes place, and we will consider one of the component is anode, second component is the cathode. So in the left hand side, we write anode. In the right hand side, we write cathode, where reduction takes place. Okay, and remember, the electron flows from zinc to copper or anode to cathode. Okay, now we'll detail discuss about what is this oxidation half cell, what are this reduction half cell. Okay, so first one, we'll talk about the oxidation half cell, and that is considered as anode. Okay, now obviously when the statement says about oxidation half cell, that means oxidation reaction must be taken in this cell. Okay, so if you consider this half cell reaction, this is the half cell reaction, oxidation half cell reaction. Okay, oxidation reaction takes place. So you see the diagram here, zinc sulfide is taken in the solution and zinc rod is dipped into the solution. So what is going to happen, as zinc is more reactive, zinc is going to lose 2 electrons. Okay, so it will becomes Zn2 plus aqueous form plus 2 electron. Now from here, 2 electron or the electron will release from the zinc. Okay, second point, loss of electron, as 2 electron has removed from this reaction, so this 2 electron is going to flow through the wire. So you can see this is 2 electron or electrons are flowing through the zinc. That is known as oxidation potential, or short form we'll write it as OP. What is this oxidation potential? As you can see that whenever in the solution only, I'm taking this solution, this one is zinc. Okay, this is our zinc. So when the zinc is going to release 2 electron, so there will be potential generated. Okay, So that potential is known as oxidation potential. And we write that half cell equation as E is known as potential difference. Zn solid, it will convert it to Zn2 plus aqueous form. So you see this half cell reaction, Zn solid has converted to Zn2 plus. So how do you know it's this oxidation reaction? So what is the oxidation number of zinc here? 0. Here it is 2. So increase in oxidation is nothing but your oxidation potential. Okay, so remember this is very important. In the further slide we're going to use the half cell reaction. So this is known as oxidation potential. Next one is standard oxidation potential. What is the meaning of standard oxidation potential? So if this reaction carried out at pressure is equal to 1 atm and temperature it is around 25 degrees Celsius and solution is taken as 1 molar. Standard solution. So if the solution is taken under this condition, then we'll call it as a standard oxidation potential. And also the other half will be standard reduction potential, okay? And that is designated with E naught. So whenever you'll find out E naught is there, that is the standard conditions. So next we'll discuss about reduction half cell. So the right part of half cell is known as reduction half cell. And it is called it as cathode. Okay. Now, which reaction will take place in this chemical reaction? Reduction reaction will take place. How? As the anode has released 2 electrons, so what will happen? Cu2 plus is going to acquire 2 electron and it is going to convert to Cu solid. As you can see that the oxidation number here it is 2 and here it is 0. So from 2 to 0, decrease in oxidation number is known as reduction reaction. Okay, and this reaction is going to gain number of electrons. So as the zinc has released electrons, here what will happen through this channel, electron is going to gain or come to carry out the following reactions. And the potential develop in between this Cu2 plus and 2 electron, that is known as reduction potential. So here you can see that here the red colors are the electrons and these are the Cu2 plus. So there will be potential generated. So if basic concept of physics says whenever two charge is there, so that create the potential difference. Okay. So here you will see that negative and positive charge is there. That is going to describe the potential, the reduction potential. How can you write the half cell reaction? Half cell reaction is E Cu2 plus aqueous solution, okay, and that is going to convert it to copper. So copper solid 0. And if the reaction carried out in standard condition as we have discussed, then we'll call it as a standard reduction potential or E naught. Okay. So this is known as, this is not ROP, standard reduction potential. Okay. You remember this one. Next part is the salt bridge. So what is the work of salt bridge? So basically it connects the left and right half cell. So here you can see that the left half cell, the right half cell, and this is the salt bridge which connect the left and right half cell reaction. So what is the work? You see that U-shaped filled with electrolyte KCl, NaCl and sodium nitrate. So the salt bridge is going to connect the left hand cell and the right hand cell, and the work is to provide the electrical neutrality. As you can see that KCl, NaCl, NaNO3, these are strong electrolyte and they are going to release their positive and negative ion very easily. So the work of this is to balance the electrical neutrality. How you can see that, as zinc has released 2 electrons and this 2 electron is going to flow through the external circuit. So there is a charge deficiency which is created in the anode, right? So all, if you'll see that the solution is plenty of Zn2 plus ion, right? So here the charge deficiency, to maintain this charge deficiency, NO3 minus is going to release from here. and they will balance the charge. Similarly, if you see that here plenty of copper is there. So what will happen when the reaction will takes place? Cu2 plus, which is in plenty amount is present, this potassium is going to balance the electrical neutrality in the right hand side or cathode. Second one, it connects the oxidation half cell and reduction half cell as we have discussed. Basically, it's going to complete the circuit, okay? Internal circuit, yes, it is going to complete the internal circuit and balance the electrical neutrality. So Daniel cell, let us now summarize whatever we have learned. Anode reaction, now tell me where the anode reaction will take place. It will take place in the left hand side. So which reaction will take place? That is going to Zn solid, it will release Zn2 plus 2 electron, okay? Now it is going to present in the left hand side and the charge is negative, it is anode, okay? And this is nothing but your oxidation potential, or we can say the standard oxidation potential, and we can write the potential as E Zn solid Zn2 plus aqueous, okay? Now talking about the cathode, where it is present on the right hand side, will the reaction that is going to take place, Cu2 plus 2 electron is going to release, and that is going to give Cu solid. So this is aqueous, okay? And it is positive charge, consider as cathode, and we'll call it as a reduction potential and standard reduction potential. The potential can be written as Cu2 plus aqueous medium, then U solid, okay? So this is the cell reaction. How can you write the cell reaction? Coming slide we'll learn how to write the cell reactions, and this is the half cell reactions, okay? I think this part is clear to you. So next we'll discuss about cell potential. So as we know that in the left hand side and right hand side, two electrodes are present which has different potential. So cell potential basically tells about the electrochemical cell in the potential difference occur between the two electrode of the cell and arises due to the transfer of electron through the external circuit. As we have discussed in the cathode and anode, electron is going to transfer from anode to cathode, right? So there create a potential difference. So due to that potential difference, we'll call it as a cell potential, okay? And cell potential is considered as E naught. Obviously, this is in standard condition, we'll write it as a cell. So E naught of cell is equal to standard oxidation potential anode plus standard reduction potential cathode. So basically, E naught of the cell is nothing but the summation of potential difference between standard oxidation potential and the standard reduction potential. Okay, so you remember this formula because in the further solving the numericals, we are going to use this formula again and again. We can rederive this formula into other form, that is going to learn in the later part. Cell representation. How can you represent any cell? First, we have to write anode, then we have to write the cathode. For an example, first Zn, okay, solid, then single line, then Zn2 plus, this is aqueous form. Double line represent your salt bridge, okay, and this is nothing but your Cu2 plus aqueous that is converted to solid. Anode is placed before the cathode, so this part is nothing but our anode, and this is our cathode. Double line represent our salt bridge, okay. Component in different phase are represented by the single vertical lines. So as we saw that zinc solid and this is zinc aqueous, so they are represented with a single line. Component in the same phase are represented with a comma. Suppose a few reactions are there where we'll find out as both are ionic form. So in that case, we'll separate them with the comma. Fe2 plus aqueous, Fe3 plus aqueous. Okay, thank you for watching this video. Please like and subscribe EDUKEM channel and share with your friends. And if you want to connect with me with my social media account, my Instagram and Twitter handle is this. So till then, thank you guys.